Welcome everybody, this is Mrs. Dunn again, and what I wanted to do in this screencast is I wanted to do an application of a linear programming problem that's in 2 dimensions using the geometric approach. So what we're going to be doing is solving an application which is a word problem. And these are the steps that you want to go through. First, you're going to read the problem and identify the variables. Next, make a chart from the information that is given to you. From that chart, you'll be able to set up the constraints and the objective function, and then you're going to find the max and min similar to the way we had done it in the previous video I recorded. So let's look at a problem. So for example, consider this transportation problem. The officers of a high school senior class are planning to rent buses and vans for a class trip. Each bus can transport 40 students, requires 3 chaperones, and costs $1,200 to rent. Each van can transport 8 students, requires 1 chaperone, and costs $100 to rent. Since there are 400 students in the senior class that may be eligible to go on the trip, the officers must plan to accommodate at least 400 students. Since only 36 parent volunteers have volunteered to serve as chaperones, the officers must plan to use at most 36 chaperones. How many vehicles of each type should the officers rent in order to minimize the transportation costs? And what are those minimal transportation costs? So remember, the first thing we need to do is identify the variables. The best way to find that information is to read all the way at the bottom of the question. What is the question asking you for? The question asks, how many vehicles of each type should the officers rent in order to minimize the transportation cost? This right here, how many vehicles of each type, that's your clue. So how many vehicles of each type indicates that our variables are going to be the vehicles. So we'll use X for buses and Y for vans. Okay, the next step is to make a chart of this information. So the variables are X buses, Y vans. So those are the vehicles, and we're transporting students and chaperones. Sorry, I went a little too fast. And also there's a cost involved. And we're going to keep track of, okay, we have a certain number of students that we need to transport and a certain number of chaperones. All right, so back to that slide. So if you look through this information, it says each bus can transport 40 students, requires 3 chaperones, and costs $1,200 to rent. 40 students, 3 chaperones, and it costs $1,200. How about the vans? They can transport 8 students, 1 chaperone, and they cost $100 to rent. Now, how did I get these figures? Remember, it says there are 400 students in the senior class that may be eligible to go on the trip. So there are 400 students, and there are 36 chaperones. So that's the most important part, guys, is setting up that chart and making sure you set it up logically. Make sure that you identify the correct variables. That's going to be the key. Okay, next step is to set up the constraints and the objective function. The objective function, remember, is we're minimizing. The question asks, what are the minimal transportation costs? So we're minimizing the cost. It's $1,200 for each bus and $100 for each van. So Z is equal to 1,200X plus 100Y. We want to find the smallest value of Z. The constraints are 40X plus 8Y, that's the number of students that are going to be transported, and that has to be at least 400. At least means greater than or equal to. And there are 3 chaperones per bus, 1 chaperone per van, and that can't be greater than 36. Don't forget, This is an important constraint that X and Y have to be greater than or equal to 0. You can't have negative buses or negative vans. So now we're going to do we're going to graph this, find the critical values, find those corner points, and then from those find the max and min. So here's a graph. Remember, we have to stay in the first quadrant, so it's where these two shadings overlap, but we have to be above the x-axis and to the right of the y-axis, so it's this triangle right here. The corner points right here, you can see this one is 10, 0. This one is 12, 0. This one is 7, 15. To find those corner points, remember you're setting each of these constraints, the equations, not the inequalities, but the equations equal to each other. Solve them by elimination or by substitution. Once you have those corner points, you're going to plug those into your objective function. So the objective function is 1200x plus 100y. When I plug in those corner points, I get these values for z. And since we're asked to find the minimum, the smallest is 9,900. So the minimum cost is going to be $9,900 when the school rents 7 buses and 15 vans. I hope that helps. Good luck with your homework. Thanks.